So it is time for us to go over this practice test. The good news about the practice test is a copy of this video will be put in Google Classroom. So when you go home this weekend and you want to study up for the test, and you're like, I'm still stuck on this, you can go back and you can watch it in your time, at your pace. Pause it when you need to. Okay? All right, let's do this. Number one, are these polygons congruent? If so, name the corresponding parts and write a congruent statement. And they are congruent. What are the congruent? L is congruent to N, so L and N have to be in the same spot. L and N are both first. Here, L and N are not in the same spot. Here, L and N are not in the same spot. Are they congruent? Well, these angles are both 90. These angles are both 25. Well, these ones have corresponding sides equal, So these are congruent, so that one would be B. Number two.
Oh, yay.
Number two over here, what about these two? This is 5.3, this is 6.1, so they are not congruent. So they're not congruent. Number three, the triangles below are congruent, which is a possible congruent statement. So what's congruent to C? G. So are C and G in the same place here? Yes. Here? No. Here? No. Here? Yes. Okay? So now I have to look at another letter. Is B congruent? What's B congruent to? F. Are B and F in the same place here? No. So it must be A. Okay? Number four. QRS is congruent to TUV. Find TV. TV is the first and last letter here. What are the first and last letters here? QS. How long is QS? 6. So that means TV is also 6. B. Find the measure of angle U. What does U correspond to? U is the middle letter. What's the middle letter here? R. So it corresponds with R. How many degrees is R? I don't know, but I do know there's 180 degrees in a triangle, and this much is 120. So if I go 180 minus 120, I get 60. So that means R is 60. That means U is also 60. C. Okay, first page was worth 5 points. Hopefully you got 5 out of 5.
4 out of 5.
Okay. Octagon. How many lines of symmetry does it have? An octagon has 1, 2, 3, 4, 5, 6, 7, 8 lines of symmetry. So lines of symmetry 8. Okay, what about angles of rotation? So I'm going to go ahead and, just a second here. I'm going to show you how I get that. Okay, so I'm going to erase these right here. Okay, so what are my angles of rotation? So I'm going to go ahead and make a copy of this. Actually, I'll just trace it. Okay, so now if I take that and I rotate it, okay, that didn't work. So let's try another option. I'm going to take a picture of it. Yeah, I hate when that happens. Okay, and there we go. Okay, and we need to make sure it's the same size. So I'm going to go ahead and, okay, and I'm going to make sure it overlaps it. Okay, so how many degrees until it's the same? 1 turn. What? 2 turns. 3 turns. I don't know. No, I don't think it's fine. 3 turns. 4 turns. 5 turns. 6 turns. Now, if you had your pencil on your paper and you were doing this, it wouldn't be sliding. It wouldn't be off like that. 7 turns. 8 turns. So how do I figure out the angles of rotation? 360 divided by 8 equals 45. So that means at 45 degrees, 90 degrees, so every 45 degrees. So these are all the angles of rotation. Write those down if you didn't in red, so you know how to do this for the test. That would be 270 and 315. We don't put 360 because everything has 360 rotation. Okay, that's the answer to number 6. Number 7, does this have line symmetry? Yes. Okay, if it does, draw the line. One. That would fold in half and it would be a reflection. Number 8, does this rim have rotation symmetry? Okay, well, if I turn it, will it be the same? Okay, what do you guys think?
Yes.
If I turn this, will it be the same?
Yes. That is correct. Yes.
Okay, we can prove it if you don't believe me.
I don't think it is.
Yeah. Okay, let's try that again.
Where? Circle of death. Not a normal kind of room.
Okay, so let me go ahead and okay, so if I put this over this and I rotate it, is this the same? Once, twice, 3 times, 4 times. I did. The middle does not matter. 5 times. So, so first of all, does it have line symmetry? No. There's no place you could cut it in half. Does it have rotational symmetry? So you go 360 divided by 5, you get 72. So it'd be 72 plus 72 plus 72 plus 72. That's the answer. Yep. Yep. That works. Okay. Number 9. Okay, so number 9. Negative 7, 7. We have to graph our shape. 1, negative 2. And 2, 5. Okay? Connect the dots. Okay, now we need to rotate that 90 degrees clockwise. Okay? That's where you need to use your tracing paper. You connect the one of the vertices to the center, right? And then you rotate it 90 degrees. And I don't know if it's going to let me do this, but we'll try it. I don't think it doesn't work on that smartboard, I don't think. Oh, I need to put my plus on the page, right?
Yep.
Yes, you do. I don't think that's straight.
Yeah.
All right, let's try this again. So now it's turned to the right. Okay?
Oh, yeah.
And that's what it should be. And then notice your new A is 7, 7. What's your new B?
-2, -1.
1, -2.
Oh, what?
No, it's not, sorry. I was looking at the old one. My bad. The new B is -2, -1. And your new C is 5, -2. Okay? That one would be worth 2 points. All right? All right, next page. All right, now we need to graph the figure and the dilation. Okay, so let's go ahead and graph the figure. We need to go from 0,3 to 2,6. From 2,6 to 4,3. From 4,3 to 2,0. And from 2,0 to back to here. Okay, that's what your shape should look like, right? Everybody got that? So we have W, X, Y, Z. Okay? If it's a scale factor of a half, what do we do to each coordinate? We'll multiply by a half. But look at what the center is. What is the center? -2, 0. So this is my center point. Okay? So how far do I go to point W? Up 3 over 2. Landon, this is really important. Up 3, right 2. What do we have to do with these numbers? Multiply them by what?
1/2.
1/2, the scale factor. So we're going to go up 1.5 over 1/2. Or, excuse me, up 1.5, 1.5 over 1. Up 1.5 over 1. That is my new, that is my new W. Okay? This one is up 6, 1, 2, 3, 4, 5, 6, over 1, 2, 3, 4. Up 6 over 4. Would be up 3 over 2. Okay, so I'm going to go up 3 over 2. 1, 2, 3 over 2. There's my new X. Okay, and I can see that the rest of them would fall there, there, and there. And here is my dilated shape. That's what you should have gotten. Okay, so remember you have to go up and over and then multiply those distances by your scale factor. And what are my new coordinates? We have W prime is 0, -1, 1.5. X is 0, 3, X prime. Y prime is 1, 1.5. And Z prime is 0, 0. Okay, so that'd be worth 2 points. Next one, centered at the origin. The nice thing when they're centered, let's go ahead and graph this. So we have 1, 3 to -2, 3 to -1, 1 to 2, 1. And then we have 2, 1 needs to go back to 1, 3. So it's a parallelogram, right? Okay? So dilated by a scale factor of 2, we just multiply each coordinate by 2. What's 1, 3 times 2? It's 2, 6. So we have 2, 6. What's that? This 1 times 2 is -4, 6. -4, 6. This times 2 is -2, 2. And this times 2 is 4, 2. Connect those with a ruler. I'm just doing this for sake of time. And label your coordinates. So this would be Q, R, S, T, and Q prime, R prime, T prime, S prime. Move, there it is. Okay. And then down here we would name our new coordinates. Yeah. No, I just graphed them where they ended up.
These should be half of that. So
Because how far is Z from there? 4 units. What's half of 4?
1, 2. Oh.
That might be the problem right there. Okay, so what is Q prime? So what are our coordinates? Q prime is 2, 6. R prime is negative 4, 6. S prime is negative 2, 2. And T prime is 4, 2. All right, over here. Triangle 4, negative 2 to 7, negative 4 to 2, negative 3. And then I need to connect those. Okay, so we have A, B, C, and we're reflecting it about the x-axis. So that's right here. So that just means my new A is 2 units above. My new B is 4 units above. So A prime, B prime, and my new C is 3 units above. Oh, whoops, my bad. I looked here, I didn't look here.
That's what I did the first time. I erased it. Me too.
Okay, so reading the directions carefully, it says first to reflect over the y-axis. So good catch, guys. So first we're going to do this. So good thing this is a practice test for me as well. So we are going to go 2 units this way, C prime. 7 units that way, B prime. And 4 units this way, A prime. Okay? Now we're going to connect those. Okay? Now it says take A prime, B prime, C prime and reflect it across the x-axis. So now this is going to be 2 up here. This is going to be 3 up. And this is going to be 4 up. Okay? And then I connect those. And I get A double prime, C double prime, B double prime. What happened when you reflected over the y-axis? X coordinates change signs. Yeah. What happened when you reflected across the x-axis? Landon, I'd write this down because this is going to be a question on the test and you're not going to have it. What happened when you reflected across the x-axis? The y-coordinate changed signs.
Yeah, that's like it turned negative.
But what turned negative?
I said the first set turned negative and that.
Please use X or Y, don't use first. Okay, number 13. So first we need to graph the shape. 6, 7 to negative 6, 8. It's about right there. To 4, negative 4. To negative 4, negative 4. Whoops. Did I do that? Well, let's write the letters before we move on. So we have A at 6, 7. B is at negative 6, 8. C is at 4, negative 4. And D is at negative 4, negative 4. So let's move this over here. It has. Okay? A, B, B, C. So we're translating it by -1, -4. So we're going to go -1 this way, -4 that way. So this is going to be down here, -1, -4, -1, -4, -1, -4. Okay, so there's B prime, A prime, C prime, D prime. Connect them. Okay, and then you know what would be the easier way to write down your coordinates? If you moved it left 1, you're going to take a 1 off of each x value. So 5, -7. I'm just subtracting 1 from each x value. 3 and -5. And then if I'm going -4, I'm going to just subtract 4 from each y. So 7 minus 4 is 3. 8 minus 4 is 4. -4 minus 4 is -8. And -4 minus 4 is -8. There's my coordinates. Right? Got that? All right, groovy. Okay. Number 14. Triangle ABC is reflected across the x and then translated 12 units. So it was moved here. Then it was translated 12 units that way. Okay. What's true about this? Okay, this is an easy 3 points.
I know, I thought it was.
Is angle B still the same?
Yes.
True. Is AC longer than side AC?
Oh, that is false.
No, it didn't change size.
True.
Is side BC the same?
Yeah,
True.
that's an easy 3 or.
Yep. True, false, true. Okay.
Oh, I circled that, I didn't answer it.
Number 15. Similar triangles. Okay? Well, but let's think about this. If I rotate this 180 degrees clockwise, they're similar. So 60 corresponds to, what is that, 71.4? No, 114. Okay. So we need to write a proportion involving D. So the height of this triangle over the height of this triangle is equal to the hypotenuse of the small one over the hypotenuse of the big one. Now it's just cross product rule. 60D equals 105 times 114. Divide both sides by 60. And we get 199.5. A. Okay. Got that? Remember, you can. I'm going to post this video, so you can always go watch it and stop, pause it when you need to. Okay, number 16. Graph the translation. Would you just put the magnet in the door so we don't have to keep doing this?
I'll do it. I got you.
So 4 units right, 3 units up. 4, 3. 4, 3. 4, 3.
Where's the padding paper? For the.
Okay, now I'm going to connect them. What is the rule if I go right 4, x plus 4? What is the rule if I do 3 units up, plus 3? Okay, let's connect them. Ooh, there it is. Okay. Well, yeah, if it goes up, it's plus.
I didn't know what the extra I thought.
Okay.
I got it right.
Next one. How am I going to get this figure onto that figure? Okay. Well, what if I rotate it at 90 degrees clockwise? Does that work? That's one. Okay, so transformation 1. And there's more than one way to do this. Rotate 90 degrees clockwise.
That's what I said.
Yes.
I did.
Okay, and then I'm going to translate it down 1, 2, 3, 4, 5 over 1. So left 1 down 5. And now what am I going to do? Reflect it over what?
The y-axis.
Over x equals -1. Okay, that's one way to do it. You're right, there's more than one way. So what I do is I look at that problem, and if you got part way there, you get a 1 point, it's a 2-point problem. If you got it, if you mapped it right onto the other one, you get 2 points. Okay?
I'm gonna be a mathist for like. What if we did it in like 2 instead of all 3?
What'd you do?
Well, I did like reflection over the y-axis and rotate over the.
Okay, if you did reflection over the y-axis, it would be like this. And then you did 180,
Not really, I did 90, not 180.
90.
Yeah.
Well, then it's going to be like, well, depending about which point you use, then it would be like this.
From origin. Oh, I tried to rotate it down.
Now, if you did it about the origin, maybe, I don't know.
I moved it down on the right 2 down 1.
I don't know. Okay. All right, next one. Is this one an enlargement or a reduction?
Yeah, you can get the
Uh-oh, okay. Sorry. Okay, real quick. Landon, pay attention, please. Here, if the scale factor is 3, I just multiply everything by 3. So this is really just simple multiplication. Okay?
Very much so.
On the next one, if the scale factor is a 4th, you just multiply everything by a 4th.
That was like 2 inches.
Okay? So all you would,
That was 2 inches.
it's just basic multiplication.
Yeah.
That's why it's good not to use a calculator, because it makes your brain stay sharp. Okay. On here, if this is a dilation, and this is 2 units wide, and this is 1 unit wide, the smaller one is half as big. So it was a reduction, and it was scale factor of a half.
That's what I thought.
Number,
I didn't see that reduction or enlargement thing there.
you stop, Landon. Number 21. What, to get from here to here, what did I do?
Slide to the left.
Didn't even have to say that. These are the easiest problems on the test.
Yep.
Which describes this one. It's a what?
Flip.
Flip or reflection.
The next one's a turn.
Okay? What about this one? Are they congruent? Rotation followed by a translation. If I rotate it,
You make some fun. I can change something on myself so I'm better.
okay? Oops, I didn't draw that right, but so I visualize it. If I turn it, and then I slide it, will it be that? Yes, A. Are these similar? They are similar because a reflection followed by a dilation. Have those been reflected? No. Otherwise, it'd be facing the other way. Figures are similar because of a rotation followed by a dilation. No, it hasn't been rotated. The figures are similar because a translation followed by a dilation.
Yes.
Yes. It was slid and then made smaller.
What was the test out of?
40
Whoa, that's
with all the multiple points. Are these similar?
yes.
A reflection followed by a dilation. Is that a reflection followed by a
Yes,
dilation?
it is.
If you reflect across that line and then dilate it, okay? So that is reflection followed by a dilation, A. Number 27. What is the scale factor here? Okay? The dash is a dilation. So it got bigger or smaller? Bigger. Did it get 3 times bigger or 6 times bigger?
3 times 3.
Okay? That one was B.
Yep.
And then this one, did it get bigger or smaller? Smaller? Whoops. Is it half as big? A 4th as big? It can't be 2 times big because that's bigger. Landon, dude, I'm concerned.
How would that be?
1, 2, 3. 1, 2, 3, 4, 5, 6. So this is half as big.
Yeah, I got
Okay,
that right.
and there it is. You have it.